So very good afternoon, all of you. I will be presenting non-destructive testing of concrete in buildings and when it is required. And I will go for some case study, 1 or 2 case studies in brief on non-destructive testing of concrete buildings. So if you go through the IS 456-2000, the concrete shall be, what is the criteria of compressive strength? So that has been given in table number 11. So the mean strength determined from any group of 4 consecutive test results complies with the appropriate limits in column 2 of table 11. Any individual test results complies with the appropriate limits is column 3 of table 3. So this is table number 11. This is without amendment. So this table is no more valid now. So there is an amendment in 2013. So I will discuss directly because this is outdated. So I will discuss this one. So characteristic compressive strength compliance requirement. So M, if your concrete grade is M15 and above, then your strength should be, suppose 4 non-overlapping test result of the cube should be FCK plus 0.825 into established standard deviation. So that is important. So whenever we are designing the mixed design, that time we are taking some other parameter, FCK plus X or mean target strength is equal to FCK plus 1.65 into a standard deviation. So that will not be valid now because that is for a trial mixed design. So once your mixed design is over, then we have to comply with this requirement or FCK plus 3 Newton per mm square. So suppose we have a M30 grade concrete, so minimum average strength of 4 consecutive non-overlapping test results should be FCK plus 3 Newton per mm square, whichever is greater. Individual test results, suppose you are testing 1 cube, that should not be less than FCK minus 3. So this is the requirement of this table. And when both the following conditions for flexural strength, that was for compressive strength, for flexural strength, the mean strength determined from any group of 4 consecutive test results exceeds a specified characteristic strength by at least 0.3 Newton per mm square. The strength determined from any test result is not less than the specified characteristic strength is less than 0.3 Newton per mm. So this is the direct codal provision I have copied and written here. And for any batch of concrete, suppose your work is a small, your concrete work is between 1 to 5. So 1 sample is enough. 1 sample consists of 3 cubes. 1 sample consists of 3 cubes. So similarly, if your work is between 6 to 15 cubic meter, in that case, 2 sample is enough, means 6 cubes at different times. Suppose your concrete work is 16 to 30, between, say, we have a 20 cubic meter of concrete work, then 3 samples is required. Suppose your concrete work is between 31 to 50, say we have a 42 cubic meter of concrete, then 4 samples is enough. But suppose our concrete, large volume of concrete you are using, so in that case, 51 and above, 4 plus 1 additional sample for each additional 50 meter cube of concrete. Okay. So again, the test results of a sample, the test results of the sample shall be the average of the strength of 3 specimens. The individual variations should not be more than plus minus 50% of the average. If more, the test result of the sample are invalid. So in this case, if your test is not passing, your concrete is not passing this test, in that case you have to go for non-destructive testing. Okay. So I have given one example of this above parameter, very small examples. So when you are going to reject a particular sample, so there is a same site characteristic required is 4.5 Newton per mm square, and characteristic compressive strength requirement is 41.4 Newton per mm square. This is the requirement. That is, you can say FCK. So beam size is 150 by 150 by 700, and cube size is 150 by 150 by 150. Because in India generally, if our aggregate size is nominal aggregate, we are using maximum size of aggregate around 20 mm, then 150 by 150 by 150 size is enough. So all has been tested at 28 days. So say we have a 0.7 into under root FCK, we will get around 4.5 Newton per mm square. So this is the requirement. So here, day one batch, we have a cube, we have casted and taken the test result at the age of 28 days. So one cube has given the strength of 36.5, another has given 39, and another is given 40.7. So our cube strength requirement is 41.4. So what is the average of these three quantity? 36.5, 39, 40.7. That is a 38.7. So this value should not be a deviation of 15%. So 0.85 into average of 38.7, that will give you 32.2. So we are making the average of these three. So this is giving 38.7. And suppose we are taking 15% more, because they said plus minus 50% of average value. So average, suppose we take 15% higher, so this will be 44.5 of 38.7. So acceptance criteria is 41.4 plus 3, 44, and individual test results should be 41.4 minus 3 means 38.4. So this is the minimum requirement of the cube here. So it should be rejected because minimum strength is 36.5 here. What you are observing, this value of this 3 cube is 36.5. So that is a variation of 15%. So okay, so our value should not be less than 38.4, but you are getting 36.5. So this can be, that is a doubtful concrete. That is a doubtful concrete. Once again, say batch number 2. Once again, we have taken one sample. One sample consists of 3 cubes. So here we have got 41.5, 37.3, and 38.4. You make an average, we got the 39.1. So once again, take a 15% length of this average. This is 33.2, and higher value of average 45. Okay. So what you are observing here, once again, here individual test result is 37.3, which is less than 15%. Okay. So this sample is also liable to be rejected if this is a doubtful case. Okay. So like this, we have to complete. So here if you take the average of all these 4, it is coming 41.4, but concrete rejected as average could also not exceed 44.4. So 44.4 you are not getting. Acceptance average value should be 44.4, because if you see the previous one here, this codal requirement, so this should be FCK plus 3. Okay. So this should comply the result requirement. So what we are observing here, so this batch of concrete has to be rejected. Similarly, I have taken for cubes also. Beam flexural test, 2-point test. It has been done for the flexure, because we will be getting here bending moment will be here and this zone, and shear force is 0. If you draw the bending moment diagram, you will be getting like this. Shear force diagram means it will be like this. Here will be there and here will be there. So this zone is having shear force 0. So throughout the world, we do 2-point testing like this. 2-point testing we will be doing. Say this is a P, this is a P. So here reaction will be P. So this value will be, say this distance is A. So this will be P into A. So if you find the flexural strength, so this value should be average should be 45.5 plus 3, it should not be less than 4.8. And individual result means minus 0.3, this is the codal requirement, plus minus 0.3, so 0.3 is 4.2 for the individual. So if you see here in first day batching of a building project, so one beam test is coming 3.32, 5.79, 3.41. So average value is 4.17. So this value is less. Similarly, if you take the 15% plus minus, this is coming 3.5 or this is coming 4.8. So this is complying here for between, it is between 3.55 and 4.88, but it will be rejected because individual test result is less than this cube or this beam or this beam. Individual result is less than 4.2. So this is not complying the bending moment flexural strength requirement. So like this, you can check this. Okay. So now we'll go for another, like this you can go for the analysis which is to be rejected. So code what say, in case of doubt regarding the grade of concrete used, either due to poor workmanship or based on the results of the cube strength test, compressive strength test of concrete on the basis of clause number 17.4, core test and or load test may be carried out. So core test also, it is a semi non-destructive in nature, and this is the only test which is going to give you the confirmatory test for the concrete. And non-destructive test like ultra pulse velocity or rebound hammer test, that is a indicative test. But final decision we have to take based on core test. And secondly, if it is a flexural members, then you can go for the load test that is given in 17.6. So we'll go for the core test. Okay. So sorry. So what say core test? Concrete is, I am just reading the clause of IS 456. Everybody is familiar. If you go to the clause number 17.4, you'll be able to see this. Okay. So concrete in the member represented by a core test shall be considered acceptable if the average equivalent cube strength of the course is equal to at least 85% of the cube strength of the grade of concrete specified for the corresponding age, and no individual core has a strength less than 75%. So first you have to, because there will be some specified value for the design, say it is a M40 grade concrete. So whatever the course you have extracted from the structure based on the decision of the engineer in charge, so that value you have to convert into equivalent cube strength, and that should not be less than 85%. That is the interpretation of this meaning. And individual course should also not have less than 75% result. Okay. So if you see, this is the codal provision 5A16 part 42018. They have changed the criteria now. So this is the latest code related to do. So this is the satisfactory failure of the cylindrical specimen. So a specimen must fail like this, because at central portion it must fail in vertical like this, and here also. So this is the typical result you can see after the testing. If you are getting the shape in this fashion, then you can accept. Otherwise, if you are getting a crack like this, so if you are getting the crack like this, in that case we have to reject that cube. So that cube will not be considered in the report, that you have to reject. Okay. So this is the, because due to the size of the machine or cutting, you may get this type of result. If size of the cube is small, less than 1 diameter to height ratio, then you can get this type of problem. Okay. So once again, I have written the same thing. This is the failure mode of cubes, and this is the failure modes of cylinder. So cylinder cube you have to cut. So what is happening here? This portion, what you are observing, here, suppose any cube is there. If you apply the load due to the platen effect, suppose any cube is here, just I will write here so that we can have a better concept here. Suppose you have a cube here. So in this cube you have a platen, because this is a fixed under the machine, top and bottom. So this is having certain Young's modulus. So this is having the Young's modulus of steel, and this is a Young's modulus of concrete. So there is a composite action between steel and concrete. So due to this composite action, and there is a friction between this platen. Okay, there is a friction between this platen. So this platen, this cube, and here machine heads have a friction. So due to this friction, this will not expand equally. So there is a force here, so it will not allow to expand. So this part of the concrete at the top or here at the bottom, this is a confined. So once this portion is confined, that is going to give you the higher result than actual result. So in design, we take care. Suppose you are designing by limited state method. So we have a cube like this, graph like this by linear in method. So say this is your FCK. So what we did for taking the platen effect, we reduced this to 0.67 FCK. So 33% we reduce the strength in design here, 33%. Okay, actually if you do the testing with respect variation, and here we take 33%. Then we provide partial safety factor here in 0.0 FCK divided by 1.5, depends here in material. So finally we are getting 0.446 FCK. So there is a platen effect. There is a platen effect. So if there is a platen effect, so due to that confinement, you will not be getting the crack like this. This vertical crack you will not get. But if the cylinder is having a sufficient length, you can get the cracks in this fashion. Okay, cracks in particularly in central zone. So if the height of the core is double than the diameter, then there you can get the actual strength. You will get the actual strength by the Saint Bernard's principle. Okay. So now you go here. Here cubes also unsatisfactory cube specimen has been shown here, so that is not considered. So if you are doing for the core test, you have to drill it properly at different location that will be decided by the engineer in charge. So that coring location and size, drilling, trimming and capping, testing. So these are the operations in taking out the cores. So core, you have to first decide the location. Even it is a column, you want to take from the central zone or if you want to take from the top zone. If it is a slab or beam, so location has to be decided by the engineer in charge. Then you have to, and generally you have to see that you extract the core from the place where bending moment is approximately less. Suppose you want to do coring in columns, so you take from the central zone, their bending moment will be least. So that location you have to give for the drilling. Then you have to cut this. You have to cut at proper, because you may not be getting this smooth surface. So then you have to cut with saw, concrete saw. And then you have to go for the capping. Capping material is there. Generally, sulfur capping is preferred because that can be reused again and again. And then you have to go for the testing. So testing will be done in compression testing machine. So what are the factors affecting the result? That is a concrete characteristic, length by diameter ratio, size effect, direction of drilling, end condition and capping, reinforcement. Suppose reinforcement is cutting in between, then certainly we are going to get the lesser value. So there is a correction formula for all that. So suppose you will not get the height to diameter ratio 2. If you are getting the height to diameter ratio, suppose we have a core, you have cut the core here and say this is the diameter you getting D. So at the process of drilling, it will get automatically broken. So you don't know at what distance it is going to broken. It may broke at 1.2 times, 1.4 times, 1.66 times, and so on. So suppose it is broken at 2D height, then correction is not required. You can say this is a correction factor. It is directly coming to 1. Suppose this height is not 2D, you will maybe getting 1.8D. Then correction factor is here. You have to go like this, then apply the correction here. This will be 0.98. So similarly, like this 1.2, 1.4, 1.6, so on. So that you have to measure. Suppose this is having a undulated surface. So you have to cut this undulated surface in saw machine and put a cap. Make it smooth. Make it smooth. There is a method of doing that. It should be very much vertical in nature, not like undulated. Otherwise, you will not get the proper result. So that you have to go for the capping. Capping, suppose you have to do a small amount and you don't have sulfur in the laboratory, even you can do with the plaster of Paris. Plaster of Paris is having very high compressive strength when it is in dry condition. But generally, in field work or other places, we use sulfur as a cap material. Okay, sulfur as a cap material. So the equivalent cube strength of the concrete shall be determined by multiplying the corrected cellular strength. So generally, suppose I have a 69 mm diameter concrete cube. Okay. So what will be the compressive strength of the core? This is the diameter of the core, 69 mm. So this is the area is 69 square by 4. This is the area, and whatever you are load getting, you will get certain strength. So in those strength, what you have to do, whatever the value you are getting, you multiply it by 5 by 4. 5 by 4 means you are multiplying by 1.25. So that is going to give you the equivalent cube strength with respect to your cylindrical strength, because we consider 25%. In design code, we take 33%, but here we increase it by 25%. So that you have to multiply it by 5 by 4. That is going to give you the compressive strength. So what this say, you have seen here in this code, what they say? The concrete in the member represented by a core test shall be considered acceptable if the average equivalent cube strength of the core is equal to at least 85% of the cube strength of the grade of concrete specified for the corresponding edge, and no individual core has a strength less than 75%. So suppose this your cube test result has failed, but if it is passing in core test, then you can accept that. Okay, so that is the meaning of this clause. Okay. So if you test, this is a practical result. Even within the member there is a variation. Say we have a M35 grade of concrete. This is based on, this is not the literature, but based on testing of some buildings. We have got this type of result. Suppose we are testing a column. You are testing a top, you will get between 22 to 27, bottom you will get 30 to 36. Wall, top में more, bottom में, top में less, bottom में more. And similarly, we have a beam. If you test the top of the beam, you will get less value, and bottom will get more value. Similarly, in slab, bottom will get always more result. So this is the problem within the member itself. There is a lots of variation in concrete. So concrete is a very much unpredictable material. So that's why we take more factor of safety. Okay. So we have a two indirect test. That is a rebound hammer test and ultra pulse velocity test. So these two tests has been recognized by our courts. So in this rebound hammer test, you cannot give the decision that your concrete, your structure should be rejected or it is unstable, or in the value basis of ultra pulse velocity, because you cannot going on taking the course from everywhere in the structure, so you have to go for this test, because you can get the similarity, you can have the assessment, overall assessment of the structure, but on the basis of that you cannot reject the concrete. Okay, so this is the diagram of a rebound hammer. Okay, and if you see the codal provisions, we have three types of hammer. So rebond hammer number is measure of a surface hardness. Hence, it is an index of hardness up to a depth of 30 mm. So this is only giving up to about 1 inch, 30 mm depth. Suppose you are testing the column or beam, so that is going to give you the strength of only surface strength, not inside. Say we are having done some curing. So what is happening? Suppose you are doing the curing, you may not be able to do the proper curing. So inside the core of the column may have very good concrete, and surface concrete may not be good because you have discontinued the curing process. So concrete may be good inside, but outer surface may be less. So this you cannot rely on that. Other factor is depends on cement type, content, aggregate, then surface carbonation, that is also very, very important, moisture condition, stress and temperatures. These are the factors which is having the problem. Suppose a surface has got the carbonation due to the carbon dioxide available in the atmosphere, or suppose a laboratory is there where carbon dioxide is more, or suppose you have a bridge where always diesel engine is passing, so lots of carbon dioxide is getting in contact. So that portion will get hardened. So carbon dioxide, what will do? If you see cement is reacting with water, there is a two component. One is CSH gel and another is calcium hydroxide. So calcium hydroxide, as it react with atmospheric carbon dioxide, that will react and make a calcium carbonate. So that calcium carbonate is having more hardness than normal surface, which is a CH gel, CH calcium hydroxide, and but their size is smaller. So due to the smaller size, what will happen? Their overall hardness will be there, but final strength will not be up to that much. Okay. So these are the factors, and we have three types of rebond hammer based on the impact energy. If you have the energy of 2.25 Newton mm for normal weight concrete, 0.75 Newton meter for lightweight concrete, and 30 Newton meter for mass concreting like dams, roads, hydraulic structure, real field pavement, etc. So rebond hammer is also having a different energy levels, and based on that you have to decide the. Based on that, you have to decide the. Sorry, I am getting one call. Hello, I will call you later. I'm in some lecture, sir. After 1 hour. Okay. Hello. Sorry. So, Srivastava ji, is it? Hello.
Go ahead.
Okay.
It's all right. Okay.
So like that, surface carbonation is important. So this is not going to give you the correct result. Similarly, we have ultrasonic pulse velocity test. Factors influencing major results are temperature, stress history, path length, moisture condition, reinforcement. Okay, so even you can do the ultra pulse velocity test, and you can make a graph between the rebond hammer number, cubes result, and ultra pulse velocity value. So if you see this latest, this has also been changed now in the 2018 code parameter. If your average value of pulse velocity by cross probing is above 4.40, then you can say this concrete is excellent. But you can't say what is the grade of concrete. If you are getting between 3.75 to 4.4, you can say it is good. If you are getting 3 to 3.7, you can say doubtful, and below 3 is poor. So in case of doubtful quality, it may be necessary to carry out further test, means you have to go for the core test. Okay, directly, nobody is saying you that you have to reject the structure directly. Okay. This is the old provision of 13311. So above 4.5 was excellent, 3.5 to 4.5 was good, 3 to 3.5 was medium, and below 3 was doubtful. And this latest whatever I have shown, this is the parameter has got changed now. Okay. Similarly, suppose new code they are telling how can you find the depth of the crack. So this is the things they have included in new code here. With the help of this ultra pulse velocity, if there is a certain cracks here, if there is a crack in the member, so up to what depth this crack has gone, so that you have to find out. Say this is the cross transducer, you have put one transducer here and receiver you have put here. So from this one you can measure the distance. Say this x distance is known, and similarly this x distance is known, that you can do. So with the help of this and velocity, we will be able to position of finding this crack depth. So that I would like to explain, because that was not in earlier code. So if you see the IS 516 part 5, so IS 516 has been divided into 12 part now, and still some of the portion has to come. So they have divided IS 516 into total 12 numbers. So let us say longitudinal pulse velocity is alpha, distance traveled in uncracked concrete. Suppose this concrete, say this concrete should not have been concrete, so then it could have traveled like this 2x distance. But since this crack is there, so this will change the path like this, this will change the path like this, and this will move in this fashion. So this distance will increase. This distance is increased. So distance traveled by cracked concrete is, by Pythagoras theorem, you can say x square plus h, where h is depth of the crack. So, you know the velocity. Okay, what is the velocity? That is nothing but distance by time. So this is the distance. So with the help of this one, velocity is nothing but displacement by time. Displacement by time. So you can calculate time t for the cracked concrete. Okay. Suppose you are checking for the uncracked portion. So uncracked concrete, you can say this length is 4x square by alpha square. Okay. So just divide it, tc square by ts square equal to x square by x, or you can calculate with the help of this h. Okay. With the help of h, you can calculate this depth of the crack, how much crack is there, because this is a surface. Suppose you want to measure this surface width of the crack, that you can use a traveling microscope and you can measure the crack width. But depth, there was no provision of measuring the depth. So indirectly you can measure the depth with the help of this ultra pulse velocity. So this is very, very important things they have been included in the code. And similarly, dynamic Young's modulus of elasticity of the concrete you can calculate with the help of this ultra pulse velocity measurement. So this was there in earlier code also. This is not the new one. So this provisions was there in old code. Okay. So with the help of this, you can be in a position of finding the dynamic modulus of the concrete. So sorry. So even you can make a chart like this, because with the rebound number and pulse velocity, you may not be knowing what is the exact compressive strength. So you can make a chart. What you do, you take the cube, a standard cube of say 150 by 150 by 150, take the rebound number and pulse velocity and draw a graph. So with the help of this, we'll be in a position of finding the relation between ultra pulse velocity and rebound number and compressive strength. So that chart you can develop, and with help of that you can approximately say what is the grade of concrete, because code say it is a poor, doubtful, excellent, like that. But by calibrating this your instrument, and as well as this is required for calibration of instrument also, and with the help of this chart, with the help of ultra pulse velocity, will be in the position of finding the compressive strength. Okay, so that can be done. So flexural test also you can do. If it is not complying this, then final test you can do on the basis of, this is the codal provision 17.6 clause in IS 456. So with the help of this, we'll be in a position of saying that this structure is liable to be rejected or not. So even I have done some testing here. Load test also I have done on some of the building and 40 bridges. So that result I'm not showing. I'm just showing the non-destructive testing result of some building. So I will just escape this. And suppose somebody was asking in previous session that how laboratory is required. So generally each and every good project have the laboratory. Much more area is not required for site testing. So you can have a small laboratory at the site. So for making the small test facilities, these are the things which I have mentioned here is required for your small laboratory. So these are the things has been written here. Okay. So similarly, you have to go for the test of aggregate. I am not going to cover test of fine aggregate. All this thing has been covered by Dr. Mathi sir, and test on the fine water requirement, test on the cement. All this thing has been discussed by Mathi, and I have given here the codal provisions. Okay, so fine plasticizers, all these things that also has to be tested. These are the codes 9103 199. So lots of codes, thousands of code is there, that provisions you have to understood. Okay, I have done some testing at Basant Bihar, New Delhi for legal purpose, because there is a dispute between the owner and client and renter related to the building. So High Court had directed to test. So I myself was there and one professor from the School of Planning and Architecture. So these two people had done the testing on that particular structure. So what there we have done? We have done the core cutting at site, ratio of ingredients of the concrete, ratio of ingredients of mortar and masonry, rebound hammer for compressive strength of concrete, ultrasonic pulse velocity, cover depth, half cell potential, carbonation depth, rebar location, crack verification, presence of retaining walls in basement, compressive strength of masonry units, chloride, sulfates. So how much amount of chlorides and sulfates were present? So all these things we have determined here. So this was the result. I'm just directly showing the result. Number of concrete cores we have collected 40. So average strength in column was 8.75 with a standard deviation of 2.07. Average strength in slab was good, 9.53. Standard deviation was 2.33. Average strength in beam was 9.8 with a standard deviation of 2.36. So you can see how less it is for RCC work. With mild exposure condition in table IS 456, minimum grade of concrete should be 20, but Delhi condition is not a mild exposure condition. This is a moderate or severe. Somewhere it is severe, somewhere it is moderate. So minimum 25 grade concrete must be there. But what we are getting here, strength is not more than 9.8, and in column it was 8.75. And many places when we were starting extracting the core, we are having the fear because concrete core itself was crumbling during the concreting, during the extraction of the core. So that is a problem we are getting. So 12 location in a structural member as it crumbled into pieces, and only loose concrete material came out on core cutting due to poor quality of concrete. So this is the status of concrete when it is not been done properly. So you must check it. Quality control is must, that you can show. So that also I have mentioned for M20 grade, that you say. So cement sand coarse aggregate ratio, have done the ratio test. Although this test ratio is having certain variation of around 10 to 15%, because you don't know the source of cement and how much percentage of silica is there. So in that case, we have tested and got 1 part was cement, 4.5 part was sand, and 9.5 part was cement in good concrete, and bad concrete it was 1:9:17. That is the reason we are getting a concrete of say M5 grade. Say it is not a more than 10. So if it is not more than 10, it is between greater than 5. So you can say it is almost M5 concrete, because that was 3-story building, and that is a combination of load bearing as well as frame structure. So frame was just only for the namesake, load was getting transferred through bearing action only. That's why that building was in condition. So ultrasonic pulse velocity test we have done, and we have got all the places pulse velocity by cross probing was below 300 meter per second. Means here also result was very poor. And we have done the sulfate and chloride carbonation depth test. There I think that was within the permissible limit for the sulfate and chlorides as per the IS 456. We have checked for the carbonation depth also. Okay, so wherever we have extracted the core, so in that hole we have sprayed the phenolphthalein indicator and checked depth of carbonation. So that was also not the problem. Okay, so we have taken 151 samples. So average strength of rebound hammer test was 19.66 with a standard deviation, you can say so high standard deviation 8.78. So you can't rely test result of rebound hammer as well as ultra pulse velocity. Okay, so that has to be satisfied by the core test. So brick I am just leaving, and masonry I am leaving. There was another building, Nirvana country in Gurgaon. There was lots of dispute, so many cases. So here also, this was also related to the consumer court. So here also you can observe here, strength of the concrete is not 20, everywhere 11.9, 11.9. So finally owner owned the case, and builders has, that is for one residential bungalow. So owner, they have been paid 1 crore rupees for the compensation of this building. Okay, so these are the IS codes you have to refer. Suppose you want to do the test and you want to go in details. Okay, so these are the codes. So thank you for giving me an opportunity to present before you.